Hello everyone, welcome back to Diksha Vedantu Foundation channel, and today is day 72 of 99% in 99 days. Today there is no sample paper discussion. What we are going to discuss is formulas and equations from all the chapters that you have in your class 10th. Out of the chapters, there are only 2 chapters from where you can expect numerical questions based on formulas and equations. So we will see all the formulas and some concept, small concept. Not this class will be not too large, it will be a small class. We will also see small concept, and we will see the formulas and equations. Also we will apply them to solve few numerical questions based on the formulas, right? So without any delay, let's start with the class. So first we are going to discuss about mirrors. There is a sign convention which is applicable to mirrors. So as you can see, if you move along the positive x-axis, you can see that if you move along the positive x-axis, you get the positive value. So anything measured in this direction is positive, anything measured in this direction is negative. For mirrors, if the object is real, then both object distance and image distance both are negative, and while solving the problems, while solving the numericals, you have to keep in mind about this sign convention. So you have to put the appropriate sign to solve the problems, right? Very important. Similarly, if the object is formed, suppose the image is formed somewhere here, so in that case, in the mirror, in case of mirror, that will be a virtual object, and in that case V will be positive. Okay, V will be positive. V is the symbol that we use to represent image distance. U is the symbol that we use to represent object distance, right? Now remember that object distance is always negative, no matter you are using lens, you are using mirrors, whatever you use, object distance is always negative. Okay. Now for two more things that you have to remember is that object distance, first of all, is always negative. So U is always negative. Now for lenses also we will use the same sign convention. What is different in that case? In case of lenses, if the image is real, then the object distance will be positive, image distance will be positive, and if the image is virtual, that is on the same side of the object, in that case we will get the image distance to be negative, just opposite. V will be opposite based on you are using mirror or you are using lens. Okay. Now object distance is always negative no matter whatever you are using. And one more thing, for concave mirror, concave surface, if the surface is concave, the focal length will always be negative. Focal length will always be negative. For convex surface, okay, maybe it is lens or maybe it is a mirror, focal length is always positive. So be careful about this. These are the 3 common things that you have to remember before solving any numerical problems based on this chapter. So for concave, maybe it's concave mirror, maybe it's concave lens, it does not matter, focal length is always negative. Similarly, if you are using convex surfaces, no matter if it is a convex mirror or a convex lens, focal length will be positive. Okay. So these 2 things you have to remember before solving any problems. Now what is the formulas that we are going to use to solve problems? So this is the first formula, that is mirror equation. Mirror equation is 1 by V plus 1 by U equals to 1 by F. Also there is a relationship between F and R, we have directly represented it here. So 1 by F, or we can write it as 2 by R. So from here we can say that R is equal to 2F. That is another relationship that you might need to remember, but we have incorporated that same in this equation itself. Okay. So if you remember this equation, everything is covered, right? Only one equation for everything. Now there is one more thing, that is magnification. Magnification basically represents the height of the image divided by height of the object. Okay. And in terms of V and U, it is given by minus V by U. You have to remember for mirrors, okay, it is minus V by U. Okay, for mirrors it is minus V by U, for lens this is slightly different, even though the definition of magnification is same, that is how big or how small the image is compared to the object. Okay, if the object is generally, if the magnification is less than 1, we say the image is diminished. If the magnification is greater than 1, we say the image is enlarged, right. Now let us move on to the example problem. An object of 4 centimeter in size, so size of the object is given, is placed at 25.0 centimeter in front of a concave mirror, okay, of focal length 15 centimeter. At what distance from the mirror should the should a screen be placed in order to obtain a sharp image. So first of all we have to find the V. So first part is talking about V. From here we have to calculate the V. Find the nature and size of the image. The size of the image, we have to use the formula for magnification to calculate the size of the image. Nature is easy, even without solving the problem you can answer it, because in the question they have mentioned that a screen. So screen is required only for real images, right. So real images are always inverted, we know that real images are always inverted. Now maybe it is enlarged, maybe it is diminished, but it will be real and inverted image. So nature means real and inverted. Magnification we can calculate while finding the size of the image. So let us start with the formula. 1 by V plus 1 by U equals to 1 by F, right. Now what is the type of the lens? Mirror. Mirror is concave mirror, okay, and placed at 25 centimeter means, placed at 25 centimeter means U is given, U is minus 25.0 centimeter. Okay, so U is given, and U is, as I said, U is always negative. And now since it is a concave mirror, so focal length will also be negative. Focal length will also be negative 15.0 centimeter. Now we have to put the values and try to calculate the value of V, that is this quantity. So 1 by V plus 1 by minus 25 equals to 1 by minus 15, right. This is the formula. Now we have to find V. So let me write 1 by V equals to minus 1 by 15. Now this was minus 1 by 25. So once you take it on the other side, it will become plus 1 by 25, right. So this is minus, this is plus. So if you multiply these two signs, what you will get? You will get a negative sign here, right. This negative sign is not coming from the formula, but this negative sign is coming from the fact that 25 is negative, right. So now if you take it on the other side, it will become positive. Now what is the LCM of 15 and 25? Maybe we are not sure. So what I can do, I can write 15 times 25, that is easy, okay, otherwise it will be difficult. 75 is, I think, is the LCM, but anyway this will be the easier one. Now what you have to do, you have to do the cross. So 25 will come here, minus 25. See, only this first term is negative, second term is positive. So while doing the cross, you have to remember minus 25 plus 15, okay, minus 25 plus 15. So after doing a calculation, you will get minus 10 divided by 15 into 25. Okay, so it will be 75 into 5. So let me do the calculation. 15 into 25. 375, right. So this is the, it will be 375 minus 10 divided by 375. Now this is 1 by V. So we have to calculate eventually what we are trying to find. We are trying to find V. So V will be, you have to take the reciprocal, minus 375 by 10, that is minus 37.5. That's why we have not cancelled 5 from the denominator, because it is easier for me for us to calculate. If there is a 10, we can simply use the decimal. So 37.5 centimeter. So this is the object distance. Now image distance. Now image distance is negative. So image distance negative represents it's a real image. Okay. So it is of the same side as the mirror, same side as the object. That means it's a real image, right? So object is real, and at a distance 37.5 centimeter from the object. Now what is the magnification? So magnification is minus V by U, that is minus 37.5 divided by minus 25. So they will cancel, right? So it will be minus negative, and it will be more than 1, right? 5 5s are 25, 5 7s are 35, then 0.5, right? So it will be 5 1s are 5, 5 5s are 25. So 1.5. So it will be minus 1.5. So it is a magnified image, and negative sign in the magnification signifies it is an inverted image. Okay. Now what is the size of the image? Size of the image, H dash, is basically magnitude of the magnification times the size of the object, which is 4 centimeter, that is 1.5 times 4, that is 6 centimeter. This is the size of the image. So we have solved all the parts. Size of the image. Nature is obviously, as we can see, that magnification is negative, V is negative. So it is a real and inverted and magnified image. So these are the 3 things that you can mention about the nature. Clear? So these things you have to mention. Now let's move on to the next part of the equations. So we are trying to find lens equation. In case of lens equation, it is slightly different, that is 1 by V minus 1 by U equals to 1 by F. So same formula, only thing is in case of mirror, everything is the formula, everything was positive. In there are sign convention there. In the lens equation also sign convention is same as the mirrors, and in the equation is itself is minus is there. Okay. So as if the U is now minus, and the magnification in this case is plus V by U. So if you see, it is plus V by U, definition is same, only thing that changes is there was a negative sign in case of mirrors, in case of lenses that is positive. So there at times it is confusing, maybe you are using plus sign for mirrors, maybe you are using plus sign for lenses, but since the magnitude is correct, you can write the magnitude of lens equation, magnitude of magnification. So magnitude of magnification is same in case of mirrors and in case of lenses as well. Now in case of lenses, we have one more thing to consider, that is power of the lens. Power of the lens is determined by 1 by F. We sometimes use the power of the lens in our chapter, next chapter, that is human eye chapter. So they might give you some value. So based on whatever is the sign of the power, you can say whether it is a convex lens, it's kind of concave lens, right? We say that concave surface focal length is positive. So if power is positive, that means it's a concave lens. Okay, if the power is negative, so then we can say this is the convex lens, right? So based on whatever lens is you are using, you can determine what type of lens you are given, right? Or am I wrong? So there is a negative no, concave surfaces have a negative focal length, right? So negative focal length means my mistake. So concave surfaces have negative focal length. So negative power means it's a concave lens, and if it's a positive focal length, obviously convex lenses have positive focal length. So convex will have a positive power as well. Okay, and in this case, whenever you are using this formula, you have to keep in mind that here focal length is represented in meters, SI unit. Okay, in case focal length is given in centimeter, then you have to use this formula. Okay, F is in centimeter. Okay, when F is given in centimeter, you have to use 100 by f. Most students I have seen, they make this mistake because focal length in all the cases they are given in centimeters. So, previous problem also we have seen the focal length was 15 centimeter, right. So, in that case what you have to do, you have to use 100 by f to convert it into normal power. Now, another example problem, let us see. A concave lens has a focal length of 15 centimeter. Now, it is a concave lens. So, it is a concave lens, okay. Focal length of 15 centimeter. At what distance should the object from the lens be placed so that it forms an image 10 centimeter from the lens? Also find the magnification produced by the lens. So, in this case V is given. Now, concave lens, you have to be mindful that concave lens always produces virtual images. Concave lens always produces virtual images. So, in this case image will be a virtual one, okay. Image will be a virtual one because rays do not meet. In reality they form a virtual image. So, that is why it is a virtual image. This distance is given, V is given, right. So, what is the sign of V in this case? So, as you can see, V is along the negative x axis. So, we can say V is negative in this case. So, in this given problem V is negative, that is minus 10 centimeters, okay. So, and also first we have to find U, okay. U is by default negative, but we will not put the sign of U while solving it. The sign of U will come automatically. What is the focal length? Focal length is given 15 centimeter. So, that is minus 15 centimeter. Concave lens or concave mirror, they both have negative focal length. So, that is why it is minus 15 centimeter. Now, we have to use the lens equation now. 1 by V minus 1 by U equals to 1 by F, okay. Or if you take the U on the other side, 1 by V minus 1 by F equals to 1 by U. We are trying to find 1 by U, that is why we have done this trick. So, 1 by U basically equals to 1 by V. What is 1 by V? 1 by V is obviously minus 10 minus 1 by F, F is minus 15. So, minus 15. Now, this minus and this minus will cancel each other. So, it will become minus 1 by 10 plus 1 by 15, right. Now, you can either do the LCM or you can do the way I have done in the previous case. In this case, I think doing the LCM is easy. So, 10 and 15 LCM is 30. So, 30 means it will be minus 3, it will be plus 2, right. So, it will be minus 1 by 30, right. So, U becomes minus 30 centimeter. So, as you can see the negative sign of U coming automatically. So, you can say that U will be on the same side as the image formed, that is the real object, and image is virtual because it is a concave lens, right. Now, we also find the magnification produced by the lens. What is the magnification? Magnification produced by the lens is V by U. So, V is minus 10 and U is minus 30. So, minus minus cancels, 0 0 cancels, it is 1/3, that is 0.33 is the magnification, and it is positive means it is an erect image, okay. That is, it is in the same direction as the object, right, and diminished. Fraction means diminished, right. So, these are the things, and this is just a part of the problem. After that they will ask you to draw a diagram from the given problem. So, you have to draw the diagram as well, but in this case what I have done, I have drawn the diagram first before solving the problem, because that helps me to solve the problem easily, right. So, the drawing the diagram is helpful in this case. This will be a say 2 marks question or 3 marks part question. Obviously, a long 5 marks question, they will give you a numerical, then they will ask you the diagram as well. So, for diagram they will get 1 mark and one more substitute question, but this will contain 3 marks. So, calculating the object distance is 2 marks and calculating the magnification is 1 more mark. So, 3 marks you can score if you know this kind of tricks, right. Now, next part is electricity, very simple. So, there are first part we have 3 formulas, that is electric current is given by I by I is equal to Q by T, and in case they ask you what is charge, charge is basically current times time, current into time, right. So, this is also a handy formula, but this formula is fine to remember. Now, Ohm's law gives you the definition of resistance. V is equal to IR. From this formula we can calculate I to be V by R, we can calculate R to be V by I. So, whenever something is given and some any other variable, two variables are given and third variable we are trying to find, we will use this formula, and this is the most important formula for your class 10th, right. So, most problems will have one or two part where you have to apply this formula to solve problems. And then we have resistance. Resistance is given by rho L by A. L is length, A is area, and rho is the resistivity. Okay, resistivity depends on temperature, so resistance also depends on temperature. Length and area, definitely resistance is proportional to length, resistance is inversely proportional to area. I have not seen super complicated problem based on this formula, but conceptual questions do come from this formula. Okay, if you have increased the length, what will happen to the resistance? If you have increased the area, what will happen to the resistance? So, conceptual questions will come. There are three questions from this part, that if you increase the length, what will happen to the resistance, but that is little higher order question. I do not expect that to come in your final exam. Maybe in case they make it difficult, but in that case you will get some more question, you can answer that. Now, let us see the example problem. When a 12 volt battery is connected across an unknown resistor, there is a current of 2.5 milliampere in the circuit. Find the value of the resistance of the resistor. Easy question. So, V is equal to IR. Okay. Battery voltage is given 12 volt. I is given 0.25 milliampere, 2.5 milliampere. 2.5 milliampere means you have to use this. Milli means 10 to the power of minus 3, right. If you are not familiar with 10 to the power of minus 3s, then what you can do? You can write that 2.5 milliampere is basically 2.5 divided by 1000 ampere. Okay. So, either you can use this or you can use this same as 2.5 times 10 to the power of minus 3. Whatever you are comfortable with, you can use that. Okay. So, resistance is basically 12 divided by 2.5 into 10 to the power of minus 3. Now, when you divide something with 10 to the powers, the beauty of using 10 to the power is that suppose this is 10 to the power of x. So, you can write this as 10 to the power of minus x. Simply they go up and change the sign. Okay. It was plus here, they become minus. If it was minus by the start, then it will become plus. Okay. So, what will happen here? So, it will be 12 by 2.5 into 10 to the power of 3. Okay. This is the resistance ohm. Okay. You can calculate it. I think if you multiply 4, it will be 4.8 into 10 to the power of 3 ohm. Now, there is a trick to calculate it. What I have done, I know that if I multiply 4 with 2.5, we will get 10. So, this is a trick. Okay. So, 2.5 times 4 is basically 10, right. So, what I have done 12 into 4 divided by 2.5 into 4, right. So, what is 12 into 4? It is 48, and we already told you that this is 10. So, this becomes 4.8. This is the trick without using calculators how to solve quickly. Okay. So, 4.8 times 10 to the power of 3 ohm, or you can say 4.8 kilo ohm. 10 to the power 3 means kilo, 10 to the power of minus 3 means milli, right. So, this is the thing. So, it is 4.8 kilo ohm. Now, this is one sample problem from your textbook. Now we have resistance of combination of resistances, right, series combination where all the resistances are added one by one. So, R equivalent is given by R1 to R1 plus R2 plus R3 plus dot dot dot. No matter how many resistances are in series, they can be simply added like this. When the resistors are connected in parallel, okay, series and parallel, I hope you remember the circuit. Series is like this, one after another. Okay, and in case of series, the current flowing through each resistance remains same. In case of parallel combination, they are connected like a ladder. Okay, and in this case the voltage across all the resistors remains same. Current is different, but voltage remains same. In case of series combination, voltage is different, current remains same, right? And in that case you can apply this law, that is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus dot dot dot. Now only if two resistors, there is a special case, if only two resistances R1 and R2 are involved, you can directly write R equivalent to be equals to R1 R2 divided by R1 plus R2. Now why to remember this? Because many of the cases, if there are only two resistors, I have seen students, they do this, write this formula correctly, but while solving they forget to take the reciprocal. So 1 by REQ, you are calculating 1 by RQ. So final answer should be reciprocal of that, that is R equivalent, right? So I have seen students, they do miss that part, and they in fact, even though they have written the calculation equation correctly, do the calculation, they are not able to solve it. So this is a shorter way for two resistors, and 80% of cases you will face only two resistors. So this is a way to shortcut way to calculate the equivalent resistance when only two resistors are involved. Okay, now there are two more laws, that is Joule's law of heating. Okay, Joule's law of heating is, main formula is H is equal to I square RT. Now from Ohm's law we can replace I square by V square by R square. So after calculations you can find V square by R into T, this is also a form, and VIT, vitamin, H equals to vitamin, so vitamin H. So that is also a formula for heat, and in higher classes when you move higher, this formula is going to be used more than these three formulas. Okay. Now another formula that is very important is power. Power is Vodafone Idea, I told you VI, okay, I square R or V square by R. So these are the three forms for power as well, based on the variables given, based on the questions that we are solving, we can use different of these forms, right? Now let us move on to the another last question of the day. Compare the power used in a 2 ohm resistor in each of the following circuits. A 6 volt battery is in series with 1 ohm and 2 ohm resistors, and a 4 ohm battery is in parallel with 12 ohm and 2 ohm resistors. So first first case is we have two resistances in series, one is 1 ohm, another one is 2 ohm. So 1 ohm, 2 ohm, and a battery of 6 volt. So we have to find the power consumed by this resistance. Okay. So what is the current? First we have to find the current in the circuit. To find the current in the circuit, what we have to do? We have to find the total resistance, R equivalent. So what is the R equivalent? In this case they are connected in series. So we know that in case of series we can simply add the resistances to find the equivalent resistance. So this is 3 ohm. 3 ohm is the equivalent resistance, and the current in the circuit I will be equals to V by R equivalent, that is V is 6, R equivalent is 3. So current in the circuit is 2 ampere. So current is 2 ampere. Now how to find the power? So power, case A. So let this case 1. So in the case 1, power is given by say P1, Vodafone Idea, or Vodafone Idea you cannot use it here because we are trying to find resistance across this resistance, right? So across this resistance voltage is not 6 volt. So you cannot use that Vodafone Idea, but what you know that current is 2 ampere, 2 ampere current is flowing here, 2 ampere current is flowing through this resistance as well. So power is equal to I square R. So here we will use this formula, I square is 2, so 2 square is 4, and R is 2 ohm obviously, so it will be 8 watt. Okay, 8 watt is the power in the first case. Now in the second case, now we are going to solve the second case. Second case, they have a circuit of 4 volt battery in parallel with 12 ohm and 2 ohm. So we have a 12 ohm and in parallel we have a 2 ohm. okay, and there is a battery of 4 volt. Both cases circuit diagram is very essential. If you don't know the circuit diagram, you will not be able to solve this question. Okay. Now, in this case, the calculating power is simple. We have to calculate the current in the circuit, current through this 2 ohm resistor, or what we can do that, we know that in parallel combination voltage across a resistance remains the same. So, 4 volt voltage is same across this 2 ohm resistor, right. So, we can calculate the power directly by using the fact that formula is V square by R. Now, V is constant for both the resistances, and V is given 4 volt. So, we can directly use this formula. That was not possible in the first case. First case you have to calculate the current because only current is constant. In parallel combination voltage is constant, voltage is given as well. So, you just need to use this formula. V square is 4 square divided by 2, that is 16 divided by 2, that is 8 watts. So, in both cases you can see the power consumed is 8 watt, and even though the approach is different, formulas are different, you have applied combination. Now, in this case parallel combination equivalent resistance is not required. So, that is what I have chosen this problem. This is very interesting concept, right. And if you want to make your future interesting, then you have to apply for Diksha Scholastic Aptitude Test, that is DSAT, which is happening across our Diksha campuses every Sunday. Only thing that you have to do, you have to fill up this form, and our representative will contact you with more details. What is DSAT? DSAT is mainly based on 3 parts. First part is a 60-minute lecture as well as a doubt clarification. So, there will be a teacher who will teach you some concept, maybe whatever concept that you have learned in your class, current class. Okay, the teacher will explain it, and whatever doubt, whatever questions that arises from the lecture, he will explain that, right. Now, after the lecture is over, then based on that lecture, okay, there will be a 60-minute aptitude test as well. So, once that aptitude test is over, based on the result of the aptitude test, a counselor will guide you that what is best suitable for you. Maybe you are thinking you are not super good in mathematics, or maybe you are not super good in physics, whatever reason it may be, but actually after attempting the test you might find out that you are suitable best for study engineering, which requires mathematics and physics, because you are not getting interest because current level of understanding is boring. Maybe you will find it interesting in higher classes. So, don't hide your talent, try to find your talent through DSAT and register for DSAT today. And also, if you like this video, don't forget to share with your friends and give me a thumbs up. I will be back with more sample paper solution next week. Till then, bye.